Hello everyone, very good evening and welcome to the BYJU'S exam prep. This is Sanjay Rathi and today we are going to discuss questions from circuit theorems. That is chapter 4 of Alexander and Sadiku, guys. Okay, and then in the first part I have discussed question from what? All the theorems. Now again we will practice more question on theorems like what? Superposition theorem, source transformation, linearity, Thevenin's theorem, Norton's theorem, maximum power transfer theorem. Okay, I think everything is fine now. Okay, now please join the session and very good evening. Now this is a question from Sadiku series and this is a actually we are starting the series so that you will get some motivation or you will get idea how to solve some questions from standard textbook like Fundamentals of Electrical Circuit, that is by Alexander and Sadiku. Now we are dealing with the chapter 4 part 2. Already I have solved number of questions from chapter 1, 2, 3 and what 4th, that is part 1. Already I have uploaded what PDF on my Telegram channel. Now very good evening Bhanu. This is my introduction. Myself Sanjay Rathi. I am having 23 years of teaching experience. I am an XIES and this is my rank in engineering services exam that is conducted by UPSC and I have trained more than 1 lakh students for these competitive exam. I think now all are ready to solve some questions. Are you ready with copy, pen and calculator? सब तैयार है कुछ क्वेश्चन बनाने के लिए, कुछ चैलेंज लेने के लिए. So if you want the PDF of this session, then this is my Telegram channel, Electronics by Sanjay Rathi, and daily dose to improve concept, daily important questions, latest information about the exams and so on. Sir, for analog electronics, just after that I will start the session for that what analog electronics, but you can solve questions from Millman and Helkias, okay, and then what Sadra and Smith. Okay, for analog. Then, guys, National Scholarship Test for GATE exam. This is golden opportunity for you. Take a step towards success in GATE exam. 29th of October means this coming Sunday, and window will be open from 9 AM to 9 PM. You can give and get up to 90% off on our program. If you want to start your journey with us, then that is for you. And give test. For this, you have to install what BYJU'S exam prep app from Google Play Store and register here. Now, a link is given in description. Then, blueprint to be a topper in GATE 2025. That is the live workshop, interactive workshop by Abhinav Negi sir on 1st of November. That is on Wednesday at 7:30 PM. So, you can join this workshop by Abhinav Negi sir, MTech from IIT Delhi. Okay, and 12 plus years of teaching experience. Now this is first question. Use source transformation. You can use any method to find the Ix, but here that is the question from what textbook. This is the practice problem. Source transformation to find Ix in the circuit shown in the figure. What is the value of Ix in this question? You have to give me the answer. Okay, then tell me what is the answer for this one. What is the answer for this question? Everyone try to solve this one. Okay. Now, okay sir, but can you take a MOSFET in EDC? Yes, I will take session on that. Just I will already you have given some suggestion now. So please everyone, please write all these topic on my Telegram channel or on this comments box. One session on MOSFET and one student asked about the other topics. So this month, in the month of November, from 1st November to 15th of November, we will take session on those topics. Okay, Shreyans, how are you? Very good evening. Now, source transformation to find Ix in the circuit shown in the figure. Then, and try to give mock test, guys, on our app. Number of mock tests are available free of cost, so you can go through that and try to solve previous year questions also. Okay, then watch this. This is 10 ohm, 5 ohm, minus 2 to 24 milliampere. That is the question number 4.22 in practice problem. So this is a practice problem. Answer is already given, but you have to solve this question. Then how we can solve? First, with the help of source transformation it is given, but directly in exam you can solve. And then I will solve by using the source transformation. For example, if you want to find the Ix, so what is the voltage at this point, like Vx? So you can say Vx is equal to 10 times of Ix. Now you can write a KCL at this point to 24 milliampere. Remember, this is the milliampere is the incoming current. What is the outgoing current? Ix. Plus what is the outgoing current? Vx minus of minus 2 Ix upon what? 5. Now you can take 5 as a LCM, so it will become 24 is equal to 5 Ix. 24 5 Ix plus what? Vx. What is the Vx? 10 Ix. So you can replace the Vx by 10 Ix plus 2 Ix and divided by 5. Now this is 10 plus 2, 12 plus 5, 17, and this will become Ix is equal to 24 into 5 divided by 7. 24 divided by 5 divided by 7. So what is the answer for this question? What is the answer for this question? 7.059, nearly equal to milliampere. That is called simple nodal analysis, right? This is called nodal analysis. But can we solve this question by using source transformation? Yes. Then it will become again very easy. How? Now you can convert this dependent source, you can convert. Then this is 24 milliampere. This is 5 ohm. Always remember, current will flow from minus to plus, so that is the direction. And this is the 2 Ix into 5, that will become 10 Ix. This is the, sorry, 2 Ix divided by 5, not multiplied, because we are converting the current source into what? Voltage source into current source. That's why 2 Ix voltage divided by 5. That is the value of the current, and this is the 5, this is the 10 ohm. Now how it can become easy? For example, these two are connected in parallel. If this is Ix, then the value of resistance is just half and it is connected in parallel, means we are having the same voltage. So value of current will be double. What is the value of the current here? Double means 2 Ix. Why double? Because it is half. Now what is the incoming current? 24 milliampere. And what is the outgoing current? Ix plus 2 Ix plus 2 by 5. 2 by 5 is nothing but 0.4 Ix. Now with the help of source transformation, it will become very, very easy. 2 plus 1, 3 plus 0.4. 3.4 Ix is equal to 24. So what is the Ix is equal to? 24 upon 3.4, and you will get the same answer, 7.059 milliampere. That is the use of the source transformation. Okay, that is the use of source transformation. Okay. Now, in exam hall, some student can do the silly mistakes here. So avoid it as much as possible. Yes, now be careful. Be careful about that. Yes, it is very risky, means what? Here I have applied the source transformation. Why? Because this depends upon what? This current source. We can't change it. Suppose if you are going to change it, then it will become very risky. Yes. How? For example, if some students are doing like this, already we have the answer. Now some students just, they will change this source. This is coming in series. Minus plus 2 Ix. And what is the current through the 10 ohm resistor? This is the 10 in series. 24 into 10, it will become 240 millivolt. Remember, milliampere into 10 ohm, 240 millivolt. And this is 5, means current through the 5 ohm is also Ix. That is wrong. Now calculate the Ix. when we are calculating the Ix is equal to, you can write a KVL here. What is the KVL here? Minus 240 millivolt plus 10 plus 5, 15 Ix minus what? 2 Ix. Minus 2 Ix is equal to 0. Then 13 Ix is equal to what? 250 millivolt. What is the Ix is equal to 240 divided by 13. And now you will get the wrong answer. So it is the wrong method, because we are converting, when we are changing this branch, so what is the current through this branch? We are getting the wrong value here. So that is not the correct one. So this is the wrong method. Yes, you have to take the precaution, because in this case we are changing this, then there is no problem, because we are not changing this value. It will remain same. And on Ix, that depend, and again we can convert the voltage source into what? Current source. Again that current source depend upon the Ix, that is the current through the 10 ohm resistor. So this is correct. So you can directly go for what? KCL. Okay, if suppose you are not comfortable, then go for KCL. Next question. Find the Thevenin's equivalent circuit of the figure. That is the question number 4.34, again from Sadiku, Alexander and Sadiku. Okay, tell me what is the answer. Now, Thevenin's equivalent. So, Thevenin's equivalent, unsolved numerical. Thevenin's equivalent means, new student, watch this. You have to find VTH and RTH. What is the value of the VTH and what is the value of RTH here? Now this is called Thevenin's equivalent across A and B. This VTH is called VOC, or RTH is called, what is the equivalent resistance seen from this terminal when all active sources are 0, active independent sources are 0. So what is the RTH you have to find here. Now how we can find the VOC? Watch this diagram. Everyone solve this question and give me the answer in comments box. Now, VOC means, this is VOC. What is this Ix? Watch this. This is the 1.5 Ix. What is the current here? Ix. Then what is the current here? 1.5 minus Ix. This will become 0.5 Ix. This is plus, this is minus. Current enter through the plus, leave the minus, and that is the 0.5 Ix. And this is the Ix. And this current will flow through the 4 ohm resistor. So what is the VOC is equal to 4 times of Ix. That is the equation number 1. Now, already we have applied the KCL at this point. Already we have applied the KCL. We have distributed the current. Now apply the KVL. So we are applying the KVL from this point to this point. This is the KVL in this path. In a clockwise direction, when we are applying the KVL, it will become minus 6 minus, this is the minus 5 into 0.5 Ix, because it is in opposite direction current. Then 3 plus 4, 7 Ix is equal to 0. 3 plus 4, 7 Ix is equal to 0. Now, this will become 7 minus 2.5 Ix is equal to 6. That has become 6. So then what is the Ix is equal to? 6 divided by 4.5 ampere. So what is the VOC? VOC will become 4 into 6 divided by 4.5, and that is 4, 3, 16 by 3 volt. That is 5.333 volt. 5.333 volt. Are you getting this answer, everyone? 5.333 volt. That is called VOC. So this is a very, very simple one, but it depends upon the dependent sources. So I have distributed the current, then write down the KVL and you can find a 5.333 volt. This is again easy question. Now how to find the RTH? Again we are having the two methods. First method, because already you have open circuit voltage, so you can use this method. VOC upon ISC. ISC means VTH upon Norton's current. That will give you the RTH or Norton's resistance. That is the formula. So already we have the VOC 16/3. Then make it short circuit. When I am making it short circuit, so what is the short circuit current here? That will short circuit the 4 ohm. What was the current here? 1.5 Ix plus minus. What is the current here? Ix. Now you can write a KVL to find the short circuit current in this direction. In this loop, and this Ix will flow, because what is the current through the 4 ohm resistor? 0. It is short circuited. So Ix is nothing but ISC. Write down the KVL. This will become -6 minus 0.5 Ix plus 3 times of Ix is equal to 0. Then what is the Ix is equal to 6 divided by 2.5, or that is nothing but 12 divided by 5 ampere, and this is Ix is ISC. Now we are having open circuit voltage, that is the 16/3 upon short circuit current, that is the 12/5. Now 16 into 5 divided by 12 into 3. Tell me what is the answer here? 4, that is 3, 20/9. We are getting the right answer, or check. What is the answer here? Okay, that is I have not multiplied. 1 minute. 5 ohm. I have missed this 5 ohm. Sorry for that calculation mistake. Good observation. We are getting the wrong short circuit current. That is called again silly mistake. Now 2.5 minus 3, that is become 0.5 Ix is equal to what? 6. So what is the Ix is equal to short circuit current, that is the Norton's current, that is equal to 12 ampere. Now if it is 12, then it should be divided by 12 only. Now what is the answer? 4/9 ohm. 4/9 ohm. Now this is the answer for this particular question, guys. Okay. Now that is one method. If suppose all complete Thevenin's is required, then already we have solved the VOC. Then it is easy to solve what? ISC. Easy to solve what? ISC. So that is what? 0.444 ohm or 444 milliohm. Now, right, this is the 4/9. But if suppose only the RTH is required, then to find the VOC, then find the ISC, it will become lengthy. In that case, what we can do, make it what? Short circuit. All the active sources 0. Then here you can connect a V volt battery or 1 volt battery, external battery, and let this is the current I. And then the Thevenin's resistance will become 1/I. Thevenin's resistance will become 1/I. Now remember, this is 1 volt. Okay. And then watch this. This is what? 1.5 Ix. What is the current here? 0.5 Ix. Same. This is plus, this is minus 0.5 Ix. And then at this point, you can apply the KCL, or here in this loop you can apply what? KVL also, so that you can find the Ix. So what is this? 0.5 into 5 minus 2.5 Ix. This is minus 2.5 Ix plus 3 Ix plus 1. is equal to 0. So what is the 0.5 Ix is equal to minus 1. So what is the Ix is equal to minus 2 ampere. Minus 2 ampere. Then at this point apply the KCL. What is the incoming current I? What is the incoming current Ix? And what is the outgoing current? 1 by 4. Then I is equal to 1 by 4 minus Ix. And what is the Ix? Minus 2. Minus minus it will become plus 2. You will get 9 by 4. I is equal to 9 by 4. So what is the RTH? 1 by I. So reciprocal of that. Again we are getting the same answer. But remember, you can use this method. Suppose only RTH is required. Only RTH is required. Yes. So this is the external voltage source I, and then but same time remember you have to make it what 6 volt is equal to 0. 6 volt, that is the independent active source should be 0, but dependent active source will remain in the diagram, and so you can find. Now it is time to give the answer for the question. Already I have uploaded in what Telegram channel. I think now it is clear to you. Already I have calculated the Norton's current, Norton's resistance, Thevenin's resistance, everything for this diagram. Now that was the assignment from the previous session. Now tell me what is the answer for this question. What is the answer for this question? Obtain the Thevenin's equivalent of the circuit in figure. Thevenin's equivalent, again you have to find the VTH, that is called open circuit voltage, and short circuit current. Or directly you can find the Thevenin's resistance. VTH. So this is a 5 ohm, 10 ohm, this Vx depends, 4Vx, 15 ohm. Now watch this. If you want to find the VOC, that is called Thevenin's voltage. This is the voltage across the 15 ohm resistor. You can take a current, right? For example, you are taking I, or in opposite direction you can take I, right? No problem. Then what is the VOC will become? VOC will become 15 times of I. Okay, first equation. Now watch this. What is the Vx is equal to? Minus 5i, because I will enter here. Vx will become minus 5i. Then you can write a KVL in this loop. 5i, because we are moving in this direction, this is plus, this is minus, but Vx is minus 5i. Otherwise you can write 5i plus 10i plus 4Vx plus 15 times of I. Now what is the Vx minus 5i? You can write 15, 15, 30i minus 20i is equal to 0. So you will get 10i is equal to 0. So what is the I is equal to 0? If the I is equal to 0, so what is the VOC is equal to? 15i 0. That is the 0 volt. Thevenin's voltage for this question is what? 0 volt. Because there is no independent active sources given in the circuit. Right? So independent active source will provide the power here, but there is no independent active sources. And that's why we are getting what? 0 volt here. Now, what about the Thevenin's resistance? That was the assignment. If you have the answer, then give me the answer in comments box. And everyone like the session now. Because if you want, then in next class we will discuss what? Very important topic, that is fifth one is not relevant. Fifth chapter, fifth is not relevant to GATE exam, but yes, it is relevant, but it is related to what? Analog. Operational amplifier, that is also given in SADIQ. Concept of network we are using in operational amplifier, but we will discuss that topic with what? Analog. Now the sixth chapter is what? Capacitor and inductor. So we will solve number of questions on capacitor and inductor next class, means tomorrow. Tomorrow at what? 1 minute. Tomorrow at same time 5 p.m. And then guys, first order transient. Again next week we will start what? Transient, first order, then second order, then steady state analysis, everything we are going to discuss. But give proper response. Try to solve all the questions, do assignments. Okay then. Now Thevenin's resistance if you want to find, then guys, in this question what we are doing, apply a 1 volt battery here. This is I. We have to find RTH, means 1 volt battery divided by I. Equation number 1. Then remember what is the current here. If it is 1 volt, then what is the current here? 1 by 15. 1 by 15. So what is the current here? I minus 1 by 15. I minus 1 by 15. That is the current distribution, and already I have applied the KCL. I out current is 1 by 15, and what is the current? I minus 15. So what is the Vx here? Vx will become 5 into I minus 1 by 15. That is 5I minus 1 by 3. Minus 1 by 3, and that is the I. Vx is equal to. Now you can apply the KVL here so that we can find the 1 by I. This is the 1 volt. You can apply the KVL minus 1. Then minus 4 Vx. 10 times of I minus 1 by 15, or you can put the Vx. What is the voltage? This is the Vx. Is equal to 0. Then this is the minus 4 plus minus 3 Vx plus 10 times of I minus 15 is equal to what? 1. Is equal to 1. This is 1. Now what is the Vx? 5 times of I minus 15. So it will become minus 15 times of I minus 15. I minus 1 by 15. Or this is also 1 by 15. Now remember, I have done the 1 by 15. This is 1 by 15. I minus 1 by 15 multiplied with the 10. Now this is plus 10 I minus 1 by 15 is equal to 1. So that is 10 minus 5. This will become minus 5 I minus 1 by 15 is equal to 1. That will become I minus 1 by 15 is equal to minus 1 by 5. So what is the I is equal to? 1 by 15 minus 1 by 5. Then you will get, find the value here. This will become 1. This will become 3 upon 15. Minus 2 by 15. And guys, 1 by I you will get minus 15 by 2, that is minus 7.5 volt, minus 7.5 ohm. So that is the Thevenin's resistance here. So what is the RTH here? 1 by I, that is minus 7 by minus 15 by 2 minus 7.5. That is the value. So KCL, KVL depends upon you. You can apply, but what is the method here? You have to find the 1 by I. Then I have I have taken some equations and so on, so that we can make it what as easy as possible. Then I have not used this one, not needed. This portion is not needed. Use this directly, right? If this is Vx, or you can if you want to make it what easy, then if the 5, if this is the 5, so this is the Vx, then what is the voltage across this? It will become 2 Vx. Again that question will become very easy. Again the question, because this is 5, the value of the resistance is double, then the voltage will be double, 2 Vx, directly proportional. So this is the minus 4 Vx 3 Vx and it will become minus Vx. 1 is equal to what? And so that it will become very easy to solve this question, guys. It's up to you. Okay, everything is fine. Yes, please. Up to this point, all the questions are clear. So now, in this case, we are getting the negative Thevenin's resistance. Yes, it is possible. Voltage is 0. And here we are getting the minus 7.5 ohm negative resistance. This is a negative resistance device. Give me the example of any negative resistance device. Any example of negative resistance device? That is the question. In comments box, give me the name. Now, next one. Find the Norton's equivalent circuit for the circuit in figure at terminal A and B. What is the Norton's equivalent? Norton's equivalent means you have to find the IN and RN. And IN and RN are connected in parallel. RN. A, this is B. You have to find here IN and RN. Now, it is very easy question. Gun diode, yes. Tunnel diode, yes. That is, tunnel diode is also called Isaki diode. And the doping is very high. Degenerative doping there in semiconductor physics. Very high doping. 1 part in 10 raised to power 3. Now, what is the Norton's equivalent? So, Norton's equivalent means you have to find a short circuit current. So, make it what? Short circuit first of all. Make it short circuit. When we are making it short circuit, so what is the current here? ISC. Short circuit means this 6 ohm is short circuited. Then, and this voltage is reference voltage, then this voltage will become 0. Then, short circuit current, you can find the Vx here. What is the Vx? What is the incoming current? 4. What are the outgoing current? Vx minus 15 by 3 plus Vx minus 0 by 3. Then this is the 3 as a LCM, it will become 12, it will become 2Vx minus 15. So this is the 15 plus 12, 27. So what is the Vx is equal to 27 by 2. That is 13.5. Check my calculation. 13.5. Now, what is the ISC? That current will become ISC, because what is the current through the 6 ohm? 0. Same current will flow here. And that's why what is the ISC is equal to I1 is equal to Vx upon 3. Vx upon 3. That is Vx 27 by 2 means 27 by 6. Okay, so what is the 27 by 6? Now you can calculate. So 4.5. Yes, it is a 4.5 ampere. This is called Norton's current or short circuit current. Always remember that 6 ohm is short circuited. Therefore, what is the current through 6 ohm? 0, and apply the KCL. Directly you can solve this question. Then again, in the same question, if you want to calculate what resistance, then again it is a very easy one. To find the resistance, this voltage source will act as short circuit, and this current source will act as what? Open circuit. Make it open circuit. 4 ampere current source will make it open circuit. Then 3, 3, 6, 6 parallel with 6. So what is the RN or RTS? Same thing. 6 parallel with 6. That is what? 3 ohm. This is the 3 ohm is the answer. Very easy. Next question. This is without dependent sources. That's why a very easy one. But again, 1 mark question. Normally students are doing the silly mistakes. Now that is the unsolved numerical. Dependent sources. That was also unsolved numerical from practice problem. I think you are solving question, guys. So number of students are regular in this session now. Are you solving question from Alexander and Sadiku? All other students? Now, find the Norton's equivalent circuit of the figure at terminal A and B. Here we are having the dependent source 2Vx. So what is the Norton's equivalent here? Now Norton's equivalent means this is IN, short circuit current here. Short circuit current means you can make it what? Short circuit. That is ISC. Very, very easy. Once you will make it short circuit, it will short circuit the Vx. So what is the value of the Vx? 0. When Vx will become 0, so what is the 2Vx? 2Vx will also become 0. And this will act as what? Short circuit. Because it is a voltage source, it is short circuited. Now the 10 ampere will divide into 6 ohm and short circuit, then definitely the complete current will pass the short circuit path. Directly you can say ISC is equal to 10 ampere. This is the Norton's current, that is what? 10 ampere. 10 ampere. Okay, Shreyans? So directly, watch this. Once short circuited, Vx will become 0, 2Vx will become 0, voltage source act as short circuit and it will follow the least resistance path, that is the 0 resistance path. What is the current through the 6 ohm resistor? 0. So ISC is 10 ampere, that is called short circuit current. Now, Thevenin's resistance or Norton's resistance, that is, we have the same method. Then remember again we can use, already we have the short circuit current. So what is the RTH? VOC upon ISC. We are having the ISC 10. So you have to find the VOC only. So VOC is nothing but Vx. VOC will become Vx. This will become 2 VOC. So we have to find VOC is equal to Vx. Now, how we can find? Watch this. This is 2Vx. Try to understand. This is the 2Vx. This is the Vx. So what is the voltage at this point? 3Vx. 2 plus 1, 3Vx. And what is the current here? Vx by 2. What is the current in this branch? Vx by 2. Now you can write the KCL at this point. So what is the incoming current? 10. Incoming current is 10 is equal to outgoing current 3Vx by 10, 3Vx by 6, 3Vx by 6 plus Vx by 2. What is the current here? Outgoing current is Vx by 2. Vx by 2. That is all to Vx by 2. 3 by means to Vx by 2, Vx by 2, it will become Vx. So what is the Vx is equal to? 10 volt. Vx is nothing but VOC. So what is the RTH? 10 divided by 10, that is equal to 1 ohm. So guys, when we have to calculate the complete Norton's equivalent, or this is also equal to what? Norton's resistance, Rn. To complete Norton's, already we have the ISC, then directly find the VOC. Then it will become very easy. 1 ohm, yes. Or if you directly, if you want to find the this is a Rn, we can find Rn 1 ohm. Otherwise, you can apply a 1 volt battery. But remember, when we are going to apply the 1 volt battery here, and that is I, external, always remember, you have to make it what? Open circuit. You have to make it what? Open circuit. Because it is a active independent source, 10 ampere open circuit, make it 0. Now it is 0. Now, this is 1 volt. That's why Vx is 1 volt. So this will become 2 volt. This is the Vx parallel. Vx is equal to 1 volt. And what is the current here? 1 by 2. What is the current here? I minus 1 by 2. I minus 1 by 2. Now you can apply the KVL in this loop. So you will write minus I, minus 1, minus 2, this is the minus 2, plus 6 into I minus 1 by 2 is equal to 0. Then this is the minus 1 minus 2 minus 3. This will become 6I minus 1 by 2 is equal to 3. This will become 3 by 6. I minus 1 by 2. That is the 3 by 6, that is 1 by 2. So what is the I is equal to 1 by 2 plus 1 by 2, 1. So what is the Rn? Rn or Rth is 1 by I, and that's why it is also 1 ohm. If only Rn is required, then you can use this method. Directly 1 volt battery, make the current source open, write down the KVL, and you can find the value. Rn is equal to 1 ohm. This is the unsolved numerical from Sadiku. Norton's equivalent. Norton's equivalent, guys. Now, next one, I think no doubt up to this point. Next question is, determine the value of RL that will draw the maximum power from the rest of the circuit. Calculate the maximum power. RL means it is based on what? Maximum power transfer theorem. What is the value of RL so that we are getting the maximum power from the circuit? RL is variable. So RL is variable means what is the method for maximum power transfer theorem? Means simply you have to find, in case of DC, find the VTH and then find the RTH, and according to maximum power transfer theorem, if RL is variable, then RL should be equal to what? RTH. And what is the maximum power then? That is given by VTH square by 4 RTH. Means if the maximum power is required, means we have to find the VTH as well as RTH both. VTH as well as RTH both across this terminal A and B. This is the terminal A and B. This is called maximum power. Normally we are getting the 2-mark question from this portion. Okay, maximum power transfer theorem or Thevenin's or Norton's. This is very, very important one, or you will get similar type of questions. Guys. Now, if you want to solve this, then what is the, first of all, there is a dependent source. What is the open circuit voltage? Open circuit voltage means, make it what? 0. Make it open circuit, RL infinite. Then this is A, this is B. This is the open circuit voltage. Remember, open circuit means what is the current in this branch? 0. What is the drop across the 4 ohm? 0. That will become VOC. That will become VOC. Then we have to find the VOC. Watch this. What is the VX? At this point 9 volt, at this point VOC. So what is the drop across the 2 ohm resistor? 9 minus VOC. This is the 9 minus VOC. So what is the value of the VX? 9 minus VOC. First equation. Then how we can find the value? You can write equation VOC minus 9 by 2, KVL, KCL, VOC minus 9 divided by 2, normal KCL, VOC minus 9 divided by 2, VOC minus 3VX, VOC minus 3VX upon 1 is equal to 0. You can take 2 as a LCM, VOC minus 9 plus 2 VOC minus 6 VX is equal to 0 because 2 will become 0. Now this is the 3 VOC minus 6 VX. What is the VX? 9 minus VOC is equal to 9. Then now you can take 3 as a common. VOC minus, this is the VOC minus 2, 9 minus VOC is equal to 9 divided by 3, that is the 3. Then it will become VOC minus minus plus 2, 3 VOC minus 18 is equal to 3. What is the VOC is equal to? 21 by 3, that is the 7 volt. Are you getting 7 volt? All students, check. VOC 10 volt. Okay, for this question, what is the VOC, guys? Chalo, I will check. VOC is 7 volt. This is called VTH. Then how we can find the RTH? To find the RTH, you can make it what? Short circuit, and you can find the short circuit current, or you can apply the 1 volt battery, or you can find the value of RTH. Then make it what? Short circuit. What is the ISC? This is called Norton's current. Then you can find the RTH is equal to VOC upon ISC. Okay. Again, if you want to find, like, this is the any value, what is this? 9, and that is a Vx. You can find a value, like this, you can put the any value V volt. Then what is the ISC? V by 4. V by 4. V by 4 you have to find. Okay, then now again 9 minus V is equal to Vx. Nine minus V. Now if you want, then you can make the calculation as easy as possible, guys. Okay, no problem. But again, you can apply the KCL. V minus 9 by 2 plus V minus 3Vx by 1 plus V by 4 is equal to 0. Take the 4 as a LCM. 2V minus 18 plus 4V minus 12Vx plus V is equal to 0. Now this is 4 plus 2 6 plus 1 7V, right, and that 4 will become 0, minus 12Vx, and what is the Vx here? 9 minus V is equal to 18. Now find the value. Four plus 2 6 plus 1 7V minus 12 9 minus V, that is the already I have replaced the Vx by 9 minus V. Yes, fine. Now minus minus plus, then you can find the V. 108 plus 18, 126 divided by 19, and then you can find the ISC, guys. What is the ISC? You are getting the 4 volt Priyansh. Check my calculation. Okay, what I have done, just RTH is equal to VOC upon ISC, then ISC I have written the V by 4. Okay, it is correct. Then this is the 9 minus V, that is the value of the Vx. Then I have written the V minus 9 by 2. Okay, it is also correct. V minus 3Vx upon 1 V by 4. I have taken the 4 as a LCM. Then it will become 2V minus 18 plus 4V minus 12Vx. Is it correct? Plus V. Okay, that is also correct. 2 plus 4, 6 plus 1, 7V minus 12. That is the 9 minus V. Vx I have done, this is equal to 18 up to this point. Okay, fine. Then 7 9 minus 108, that is minus 12 plus plus 7 plus 12 19 V, and that is yes. Okay, then what? Once you have the V, once you have the ISC, then you can find the RTH. So what does that tell me? VOC and ISC. ISC is what? V by 4. Now ISC is equal to V by 4, that is 126 divided by 9 divided by 4. 19 divided by 4. So what is the RTH or RL? VOC upon ISC. You have calculated VOC 7 divided by that value to 4. Okay, calculate and then give me the answer. What is the value here? Now, what is the value of RL? Calculate. If you have the calculator, then you have to use what? Virtual calculator. Then 1 minute, give me. Yes, I have calculator. What is the answer? What we are getting? 4 point something. Okay, 4 point something ohm. That is the answer. To check my calculation, but this is the given 4 point something. Or once you will get the value of this value, again I will check. .22 ohm. This is correct one. And then what is the power? VTH square by what? 4 RTH. Remember, VTH is, already we have calculated, VTH 7 square upon 4 times of 4.222. This has become 2.90 watt, and that is the answer. Maximum power delivered to load is 2.90 watt. Okay, and that is the answer. Yes guys, that is the Shreyans, you have given the right answer. To do calculation, that is my way. I am finding the ISC and VOC. You can directly go for what? Directly you can apply what? 1 volt battery here, and then you can find. Make it what? Short circuit first of all. Remove the RL. Remove the RL here. In place of RL, you can put a 1 volt battery here, or 1 ampere current source also you can put. This is the 1 volt battery. This is I. And then guys, what is the RTH? RTH will become 1 by I. Okay. Then what is the voltage? This is the Vx. Like you are choosing the any voltage V. That what is the relation between V and Vx? Vx is equal to minus V. Vx is equal to minus V. Then this will become my minus 3V. Then you can apply Vx by 2. Just I am giving V by 2. Which method is more easy? V by 2. V minus of minus 3V. That will become plus 3V upon 1 plus V minus 1 upon 4. V minus 1 upon 4 is equal to 0. You can take 4 as a LCM. 2V plus 4V plus 12V plus V minus 1 is equal to what? 0. That 4 will become 0. 4 plus 2, 6 plus 4 plus 2, 6, 7, 19V is equal to 1. So V is equal to 1 by 19. So what is the I is equal to? I is equal to 1 minus 1 by 19. 1 minus 1 by 19 by 4. You will get 19 minus 1, that is what? 18 divided by 19 into 4. Okay, that is 9, this is 2, 9 by 38. Okay, then 38 by 9 is the value of RTH. So 38 by 9, that is the value of RTH. you will get directly 4.222. Now, if only the RTH is required, what is the value of RL so that we will get the maximum power, then this method is very easy. 1 by I, make it short circuit, very simple KCL, KVL, and then directly you can find 9 by 38 or 38 by 9, that is the value of RTH, 1 volt battery. So, if suppose we are solving question by two different methods, then we can judge, during exam we can judge which method is more easy and which method will take less time. So this will take very less time, because to calculate the ISC again we have to do some more calculation here. We have done the calculation, but calculation wise it is lengthy. Okay, so that is my way to solve the question by different methods. Now guys, it is time to solve, time to give some homework, but before that, All India Open Mega Mock Test guys, GATE 2024, Civil, Mechanical, Electronics, Electrical and Computer Science, 28th October to 3rd of November. You can join this for this, but first of all you have to install BYJU'S Exam Prep app from Google Play Store, and then register for this, and tests are available here. That is the schedule for the electronics engineer. Similarly, we have the schedule for the electrical engineer. For more detail, go through the link given in the description and start giving the mock test guys. Now it is time to give some homework. Please everyone try to solve this question. This is homework for you, and give me answer on my Telegram channel. I will provide you the solution there. Very easy question. Calculate the current I naught in the circuit of figure. What value of input voltage is necessary to make I naught equal to 5 ampere? Okay, that is a very important question. First of all, first question 4.1. Then another very important one guys, this one again, that is the 4.25 unsolved numerical from the Sadiku, because here we are having the battery with 1 volt, so there is a V naught. We have to find the value using the source transformation. Find the value of the V naught. At this point you have to find the value of the V naught here. Give me answer my Telegram channel. Then again, okay, this is a Thevenin's as well as Norton. Obtain the Thevenin's and Norton's equivalent of the circuit with respect to terminal. Third homework. Okay, so there are 3 homeworks. Try to give me the answer on my Telegram channel. I will check and then I will provide you the right answer for these questions guys. Okay, and if you want to post your detailed answer, then okay, I will check whether your approach is right or wrong. Okay, then you can install the BYJU'S Exam Prep from Google Play Store. If you are giving the mock test, then it is a leaderboard. What is your rank? What is your score? And how many students are participating in this? Everything you will get. Okay, and if you want the link, then that is given in description. And this is a crash course for GATE 2024. Complete syllabus coverage. Again, we are having around 3 months. Right? Okay, 90 days. So 90 days you can use live classes, recorded lectures, study material, practice quizzes and mock tests are available. Or if you have the long-term vision, then Vision GATE 2025 and 2026, you can join now. Courses for ESE and GATE electronics and electrical aspirants. Complete syllabus coverage here. That is for electrical branch as well as electronics branch. Right? For more detail, again you can call at this number. तो भाई जल्दी, जितना जल्दी हो सके, अगर आप सोच रहे हैं 2025 और 2026 के बारे में, then you can start your preparation now. And that is my Telegram channel, Electronics by Sanjay Rathi, where I will upload the PDF of this session as well as the answer of the question, assignment questions. Okay, thank you for attending the session. You are on BYJU'S Exam Prep. Like the session, share the link of this session and subscribe our channel. Thank you.